Let's do two more astronomy-themed unit conversions. So we're going to think about the supergiant star Betelgeuse. This star is about in the top 10 of the brightest stars in the sky. Usually during last winter and spring, it was going through an unusual fluctuation in its brightness, which we'll talk about more this semester. But in any case, this star is a supergiant star. It's so large that it can actually be resolved. That means we can see it really well as an extended source by most advanced telescopes. Usually stars are so far away that in a telescope we can only see it as one little pixel, one point. But this star is so large we can actually see it as an extended object, which is quite unusual for us to be able to do with stars, other than our sun, of course. In any case, Betelgeuse's mass is 2.31 times 10 to the 31 kilograms. Okay? And we want to calculate its mass in terms of solar masses. Now, often we compare the sizes of stars to the size of our own sun, and one solar mass, which I'm going to represent as an M with a circle with a dot. That circle with the dot represents the fact that we're talking about the sun. So one solar mass is equal to 1.99 times 10 to the 30 kilograms. So if we're going to find out the mass of Betelgeuse in terms of solar masses. So this is Betelgeuse, and how we spell it is B-E-T-E-L-G-E-U-S-E, not juice. Okay, it's G-E-U-S-E, okay? So this will require a conversion factor, and we have it right here. We know that one solar masses is 1.99 times 10 to the 30 kilograms. So if we want to calculate Betelgeuse's mass in solar masses, we're going to take this and multiply it by the fact that we know that there's 1.99 times 10 to the 30 kilograms in one solar mass. Okay, our units of kilogram cancel on top and bottom, and so we take 2.31 times 10 to the 31 divided by 1.99 times 10 to the 30 to get our answer in solar masses. So you could take 2.31 divided by 1.99 times 10 to the 31 minus 30, because we're essentially dividing these numbers on top and the bottom here, kilograms. And so that equals 1.16 times 10 to the 1 solar masses. Oh, I'm sorry. This unit is not kilograms. This unit should be solar masses, because our units of kilograms canceled on top and bottom here. So this is solar masses. So Betelgeuse is 1.16 times 10 to the 1 solar masses, which is the same thing as 1.6 solar masses, or 11.6 solar masses. So this tells us that Betelgeuse is actually 11.6 times more massive than our own sun. Here's a more complicated astronomy-themed unit conversion. So let's talk about the Crab Nebula. Nebula is just a fancy word for a cloud of gas and dust. The Crab Nebula is a supernova remnant. It's the explosion of a massive star at the end of its lifetime. It looks very beautiful in some of these composite telescope images that we have of the Crab Nebula. And it's currently about 6 light years across, 6 light years wide. A light year is the distance that light can travel in 1 year. And it is expanding at a rate of 1.5 times 10 to the 3 kilometers per second. That's 1,500 kilometers per second. Okay? We're going to convert this into miles per hour, so you can see what this looks like in miles per hour, which is a unit that you're more familiar with. You know, we drive our cars in miles per hour. And we're going to write our answer in scientific notation. So this supernova remnant is expanding outward at a rate of 1.5 times 10 to the 3 kilometers per second. We want to get it into miles per hour. So we're going to use conversion factors, right? So we got to get kilometers into miles. We've got to get seconds into hours. Okay, so let's do that one first. Let's go seconds into hours. So we know that there are 60 seconds in 1 minute. And we know that there are 60 minutes in 1 hour. Okay, and so we've got our seconds canceling with our seconds here on this conversion factor. We've got our minutes canceling with our minutes in that conversion factor. And then that leaves us with the hours that we're looking for, at least for the time unit. Now we got to get from kilometers into miles. Okay, now this is something that you would have to look up either online or in a textbook, an appendix in the back of your textbook. But the conversion from kilometers to miles is that in 1 mile, there is 1.61 kilometers, okay? And so students often ask me, well, Dr. Weber, how do I know which in my conversion factor, which number goes on the top and which number goes on the bottom? Well, you need to think about what you need to cancel out, okay? We needed to cancel out the kilometers. And so in our conversion factor, that means that our kilometer has to be on the bottom so that we can cancel the kilometer on the top with the kilometer on the bottom. And then you put the thing that it's equivalent to, 1 mile here, on top. And so that's what you would think about for this conversion factor here. So now we are left with units of miles on the top. We've got our mile per hour. So, and remind yourself, we were going from kilometers per second into miles per hour. Okay, so now you take 1.5 times 10 to the 3 times 60 times 60, and then you divide it by 1.61 to get you your answer in miles per hour. And that answer is 3.4 times 10 to the 6 miles per hour.